This webinar is sponsored by NEC Corporation, a $37 billion technology leader with over 100 years of innovation. Their ProgrammableFlow Network Suite was the first commercially available enterprise-class SDN solution to leverage the OpenFlow protocol. Thank you for your time and interest in NEC's ProgrammableFlow Network Suite.
This sponsored webinar is one of many IP Space Data Center webinars. You can register for live sessions, buy the recordings, or get access to all of them with a yearly subscription. For more information, visit ipspace.net/DC. Here, yet again, whatever I'm mentioning are extensions to OpenFlow 1.0 because OpenFlow 1.0 doesn't really have a lot of quality of service built in. And what we can do with Programmable Flow Controller is we can do traffic classification. And then after the traffic is classified, we can do 3-color policing. So the dual token bucket with committed and peak information rate and variable burst sizes. And based on the 3-color policing, we can do 802.11p marking or DSCP marking or packet dropping. And once you have 802.11p marking in place, you can start doing priority queuing in the physical switches, which is done by default because this is how 802.11q says you should do it. And additionally, you can configure different types of queuing or queuing based on different values directly on the physical switches. But what you really should be doing in a well-designed network is you set up generic QoS rules. So you say, I have this priority classes and I want to allocate this much traffic to this particular priority class. And then you configure that on the physical switches. And then you're done and you leave the switches alone. And you do all the rest of the QoS work through the Programmable Flow Controller. And here is an example of traffic policing. So I'm matching web traffic, which is all traffic going to port 80. And then I create a policing profile where I match this. I meter with committed and peak information rate. Green action means I'm within the committed information rate, so I pass. Yellow action means I'm between the two. So I can apply some penalty, and penalty is set DSCP value or set 802.11p value or set a drop precedence. And after I'm above peak information rate, I drop it. And you can apply policing actually on the ingress external interfaces. Now you can configure it on vBridges or on the whole network, but this is a templating operation. So when you configure a policing profile on a vBridge, it's actually applied to every ingress interface connected to that vBridge. And when you configure a policing profile on a VTN, it's actually applied to every external interface of that VTN. You see, it's pretty easy to configure generic traffic policing. You apply it to a VTN as such, and it's automatically applied to every single port of that VTN. And by the way, if an external port is a VLAN on a physical interface, then obviously traffic policing works on that particular VLAN of that interface. Then there's traffic marking, and I already mentioned that you can do traffic marking based on the policing results, or you can do traffic marking with traffic filters. So we've mentioned the traffic filters before. Apart from the pass action in the traffic filter, there's also the set action where you can set different fields like DSCP marking. If you apply traffic filter on any interface anywhere in the network, remember that all this heavy lifting is done on the ingress switch. So in most cases, if you apply traffic marking anywhere in your virtual network, actually the marking takes place on the ingress switch and works and affects end-to-end queuing. This is something where the Programmable Flow Virtual Tenant Networks are totally different from what we are used to do in the physical networks. What about the difference in bandwidth? 1 gig in access versus 10 gig in core, and QoS metering. How does that work? Well, actually, you configure QoS metering on the ingress interfaces of the virtual tenant network. You could say I have this physical device and it's connected to a layer 2 segment, and I'm applying an inbound policing on this particular external interface. So remember, policing is always applied to external interfaces. So in our case, it would be applied to this external port. Or you could apply policing to a layer 2 segment, in which case it would be applied to both external interfaces, so it would be applied to this port as well. Or you could have the automatic VLAN mode, in which case the controller is automatically creating vExternal interfaces as things appear, and in that case the policing would automatically be applied to external ports to which these particular devices are connected. So you would never ever apply policing to an internal port. It's always on an external port. So the speed difference doesn't matter because you're always metering traffic coming directly from an external source. If you have questions after watching this video, send a tweet to @iOSHint or send me an email using contact form on ibspace.net, where you'll also find information about other data center webinars. For all commercial questions and ProgrammableFlow evaluation requests, please contact NEC.